All right, we're looking at the solving exponential equations video. This here, so an exponential equation, this means that the variable is in the exponent, right? So anytime you see solving exponential equations, or anytime you have to solve an equation where the variable is in the exponent, this is what you need to worry about. This is the process that we're going to use to solve those. Okay, so I'm going to do this. I'm going to do this by example. So here we're going to start with an example, and then over here I'm going to write out the procedure. And I've done this a couple times in class. Hopefully this makes sense. So the example that we're going to do, let's try 6 raised to the x power equals 99. Okay. So the procedure, the first thing we want to do whenever we're solving an exponential equation, again, the variable's in the exponent, so 6 raised to the x power, right? My variable's way up here. And, you know, could it be a 2, right? 6 squared is 36, so it can't be 2. This isn't even close to that. And 6 times 36 is 216. So, you know, it's not quite, yeah, it's somewhere going to be between 2 and 3, right? So exactly what is that value of x? All right, so our procedure, first thing we need to do, and in this case, for this example, we don't have to do this first step, but we will on some other ones. So we need to isolate the base with the exponent. So when I say isolate the base with the exponent, the base here is 6. Is there a number in front being multiplied? Like, is it 3 times 6 raised to? No. Is there a number being added or subtracted behind it? So is it 6x minus 25 equals? No. It's just 6 raised to the x power equals 99. So first step in the procedure here is done. And there's going to be a couple other examples where that's not quite the case. And then step number 2, it says to take the log or the natural log of both sides. And now I'm going to tell you this. My personal preference is to use the natural log. A lot of people are going to get real upset with me because natural log is uncomfortable. It's hard to say and write at the same time. Natural log starts in L, but I'm going to write L in. That's tough. So just to be as easy as I possibly can now, I'm going to train myself to use log to help you. So take the log of both sides. So log base 10. I'm going to take log base 10 of both sides. Excuse me, I said log base 10 of 99. So now here, excuse my typo, I apologize for that. Log base 10 of 6 to the x equals log base 10 of 99. Okay, now step 3 is the exponential property of logs. I get to now take the x from here and bring it out front. So now I get x times the log of 6 equals the log of 99. And then dividing both sides by log of 6 divided by log of 6, x now equals the log of 99 divided by the log of 6. And what I did there is I solve the remaining equation. Now, the log of a number is a number, and I am treating it like a number. If this said x times 7 equals, I don't know, 28, or 7x equals 28, you would divide both sides by 7, right? So the variable times a number equals a number. I'm going to divide by that number, right? So treat logarithms, logs of a number, right? So the log of a number, treat it like a number. And I'm going to go ahead and write this part out. Once I get x by itself, so then I'm going to use the calculator whenever I get x by itself. And for you guys, most of you guys, you can use Desmos. Again, you can hop on Desmos and write log of 99 divided by log of 6, and it's going to kick back the right answer. I happen to have one of my calculators from school, so the log of 99, close parentheses, divided by the log of 6, and it kicks back x equals 2.56 4585219. All right, so the directions are going to tell us exactly where to round. So if I round to the nearest thousandth, that's going to be the third decimal place. 10 thousandths would be the 4th decimal place. So I'm going to log to the nearest 10 thousandths because I think that's what the worksheet says. So 2.56458 would make that 5 a 6. So I get x equals 2.5646. That would be my answer. Okay. Now, just a note here, or the log of a number is a number, and we treat it, T-R-E-A-T, treat it like a number. So the log of a number is a number, and that's the word treat, so we treat it like a number. Okay, the log of a number is a number, and we treat it like a number. So let's take a look at a couple of other examples. Again, if I go too fast, the beauty of you having this on YouTube is that you get to pause it. Sorry. Here we go. Sorry, not sorry, said the Reese's commercials that we saw the other day. Yeah, that's right. I watched exactly 2 hours of TV last week. Unlike you got to watch the whole thing. Another example that we have. The whole thing. What's the whole thing? I don't know. E to the x minus 1 minus 5 equals 5. Okay, so following our procedure, first thing we have to do is isolate the base, right, with the exponent. Well, the base here is e. So e raised to the x minus 1 minus 5 equals 5. So it's not isolated because I have this minus 5 here. So I have to add 5 to both sides first. So then I get e raised to the x minus 1 equals 5 plus 5, which is 10. Now, here's where I try to use the natural log as much as possible. Because I have a base of e, I'm going to use the natural log. So here, I'm going to take the natural log of both sides. So the natural log of e raised to the x minus 1 is equal to the natural log of 10. Now, why did I do that? So x minus 1 is the whole entire exponent. The exponent, x minus 1, comes out front times the natural log of e equals the natural log of 10. Now, the natural log of e. Natural log of e, so the natural log of e, so this is some scratch. This is just to help you understand what's going on. Natural log of e is log base e of e. And what's log base e of e? Good. 1. So x minus 1 times 1 is just simply x minus 1. And that whole thing equals the natural log of 10. And now I add 1 to both sides. Add 1. So x now equals. The natural log of 10 plus 1 is not the natural log of 11. It is the natural log of 10. The argument is 10 and then plus 1. So now I go to my calculator or Desmos or whatever you got going on, and we're going to say the natural log of 10, close the parentheses, plus 1, bingo bango, 3.3025, so 3.3026. So we get x equals 3.0, what did I say? 3.3026, 3.3026. That's why we don't math and pen. Okay. Now, next example. Let's do one more, which I think is really an interesting one here. Okay, let's do, let's do one more that looks a little bit difficult. So -2 times e raised to the 7x plus 5 minus 10 equals -17. Gross, and that's okay. Be patient with it. First, we're going to add 10 to both sides. In fact, the way I look at this, to isolate the base, when I go to isolate the base, if I were to cover that up and look at it like x, if I gave you -2x minus 10 equals -17, think about what you would do here in a problem like this. I know the shadows. I'm sorry. I'm so sorry. You can send me a strongly worded email like next week. It's fine. If I handed you this, the first step you would take is add 10 to both sides, right? Add 10, then divide by -2. Well, here, in order to get my base, which is e. In order to get my base by itself or isolated, I have to add 10 and then I divide by -2. So here I'm going to add 10 to both sides. So now I get -2 times e raised to the 7x plus 5 equals -7. Okay, -17 plus 10 is -7. Divide by -2, divide by -2. So e raised to the 7x plus 5 equals a positive 7/2. Where are you at, Mr. Stevens? There you are. Sorry. So sorry. Okay, now base e again, right? With that base e, let's take the natural log of both sides. So when I take the natural log of the left side, I get the natural log of e times 7x plus 5 equals the natural log of 7/2. Now, this whole entire exponent comes out front. So 7x plus 5 times the natural log of e equals the natural log of 7/2. As we've discussed before, the natural log of e is just 1. So he is gone. And I'm now left with 7x plus 5 equals the natural log of 7/2. The log of a number is a number. Treat it like a number. So 7x plus 5 equals a number. We're trying to get x by itself. So subtract 5. So now 7x equals the natural log of 7/2 minus 5. Divide by 7. Okay, and now x all alone equals the natural log of 7/2 minus 5 all over 7. That I can now go plug in my calculator. So in my calculator, we start natural log 7 divided by 2. So the natural log of 7/2 minus 5. Ooh, I forgot to put all that in parentheses. So I can go all the way back to the front and I can hit insert parentheses. So the entire numerator is being divided by 7. Not 77, you son of a, okay? And now I can hit boom bang and I get negative 0.5353. So x equals negative 0.5353, and that is my final answer.